All right, guys, today we are in section 15.6, the converse of the Pythagorean Theorem. So in 15.2, we learned the Pythagorean Theorem. Can you guys say it with me? A squared plus B squared equals C squared. All right, and we know that A and B form the legs of the right triangle, which forms the right angle. C is across from the right angle. All right, so we're going to use that same theory in today's lesson. Okay, do you guys have the review section on your notes? All right, let's just kind of just go through this. You don't necessarily, we can just kind of answer them more or less mental math. All right, but I do want to review what we learned yesterday. Okay, so anytime I'm taking the square root or the cubed root, I need to consider whether or not it's a perfect square or a perfect cube. So when I see the square root of 144, is that a perfect square?
Yes.
Okay, can I take the square root of 144? What is it? 12. So because I can take the square root, would that mean that this is a rational or an irrational number?
Rational.
It's rational. And what kind of a rational number is it?
A perfect
What kind of number is 12? Is it a repeating decimal? All right, so remember yesterday we talked about the kinds of rational numbers. We have integers, we have whole numbers, we have repeating decimals, we have terminating decimals. This is a whole number. This is a whole number. Now, is it also an integer?
Yes.
Yeah, okay. As long as you give me one of the categories, we're good. All right, now the cubed root of 200. So you have to decide, is 200 a perfect cube?
No.
So because your answer is no, it is irrational. And my reason is it's not a perfect cube. Okay. What about my next number? If I read it, I feel like I'm going to kind of give it away.
10. Oh, we were doing that. Rational.
All right. Would you say rational or irrational?
Rational.
It is rational because what kind of number is it?
Repeating.
It's a repeating decimal. We know that repeating decimals are always rational because they have a pattern of predictability. I know the numbers that are coming next. Rational, repeating decimal. Now I want to approximate the square root of 29. And we'll just do it to the nearest integer. Okay, so just real quick, you can even do this mental math. That would be okay. I want you to approximate the square root of 29 to the nearest integer. All right, so what perfect square is it closest to? 25. All right, now I'll just write the perfect squares on both sides. All right, so 29 is the square root being compared. 25 is only 4 units away. 36 is 7 units away. So I know the square root of 29 is approximately, what's the square root of 25? 5. Now, the actual square root of 29, do you think it would be more than 5 or less than 5? It would be more, right? Because if the square root of 25 is 5 and 29 is more than 5, if I actually took the square root of this number, it would be more. And that's helpful when you're comparing, when we did that comparison example yesterday. We're going to do a lot more review tomorrow. Okay? So coming back to Pythagorean Theorem now. My converse theory. So converse means in reverse. Okay? So in 15.2, I said basically that it was a right triangle and I could solve for an unknown side length. Now what I'm saying is, if I know all of the side lengths, you are not solving for a side length here. If each side length can be plugged into my formula, if a squared plus b squared does in fact equal c squared, if that is true for the side lengths, then the triangle is a right triangle. So you're going to test values here. And when you plug in the values into your formula, if they equal out, then it is a right triangle. All right, so you're going to see this in two different formats. Sometimes you would see it in a picture. All right, like we see here. We have 9 centimeters, 40, and 41 centimeters. Now, on these problems, we will not have a box showing the right angle because the box would kind of give it away, wouldn't it? Okay, so I have to use my other rules for my side lengths. One rule specifically to make sure I plug in the numbers in the right place in my formula. Does anybody remember what we said about the length of the hypotenuse compared to the other side lengths? What do we always know about the length of the hypotenuse? It's bigger than everything else. Do you guys remember that? Yeah. So I'm going to use that fact on all of these questions, that I know the hypotenuse is always the longest side length. So I don't have to figure out, like on this red triangle over here, it might be kind of hard to figure out, all right, which one is supposed to be the hypotenuse if I'm looking at the right angle. But if I know the hypotenuse is supposed to be the longest side length, doesn't that make it easier? So, for example, on the green one, which one is my longest side?
41.
So that's automatically C. Okay? So your longest side length is automatically your C value. Now, does it matter what order you write A and B? Nope. Okay. All right, so here we go. 9 squared plus 40 squared equals 41 squared. Okay, what's 9 squared?
81.
81. Do y'all remember the mental math way for 40 squared? Okay. 4 times 4 is 16. Then because that means 40 times 40, that's 2 zeros. 1600. Equals, now I don't mind, you can use your calculators. Okay, 1681. So now I have to simplify the left side. What is 81 plus 1600?
1681.
All right, and my rule says if both sides equal each other, yes, this is a right triangle. Okay, if both sides equal each other, which means that this is in fact a right angle. Even though the box wasn't there because they didn't want to give anything away, I do know that that has to be a right angle there. This has to be a right triangle because my side lengths proved the Pythagorean theorem true. All right, so now let's look at the red triangle. Same formula, a squared plus b squared equals c squared. I want you to try to plug in the numbers where you think they go in the formula. I'm just going to pause here for a sec. All right, did you plug in your numbers where I plugged them in? Did anybody say 12 squared plus 18 squared the other way? No. Okay, so if you wrote 12 and 18 the other way, that's still fine as long as 24 squared is on the other side. All right, so what is 18 squared? 324 plus 144 equals 576. All right, so now I have to simplify the left side. 324 plus 144 equals 468. So draw a line through the equal sign, not a right triangle. So what we're saying when we write this statement, and I want the statement, okay, on your homework tonight, is we're saying that we understand what we were actually trying to solve for, okay? If all you say is no, well, do you know what you're saying no to? For example, I gave a test yesterday to pre-algebra, and we kind of went through this same, reasoning. You need to write the statement. And when they wrote the statement, I could see some people understood it, some people didn't. Okay, so it's important that we always know what we're solving for here. We're trying to prove whether or not it's a right triangle. So now you're going to be given the information in a different format. You're just going to be given 3 random numbers.
Oh, so that's easy.
So how do you know?
The biggest one is the biggest.
How do you know which one goes where? Now, does A and B matter which way?
No.
Nope. How do I know which one is C?
It's the biggest number.
It's the biggest number. So 20 squared plus 21 squared equals 28 squared. All right. Now, do we need a calculator for 20 squared? No, we don't. What's 2 times 2? 4, because it's 20 times 20, and that's 2 zeros. It's 400. Plus, now we can do 21 squared real quick. 441 equals 28 squared, which is 784. Did y'all get 784? All right, so now I need to simplify. Can I say no right now without simplifying?
Yes.
No, I cannot. I can't. Even though you're probably reading into this knowing there's no way they're going to equal, you need to show me the final totals on both sides. Draw a line through it and give me just a 4-word explanation here. Not a right triangle. On big ideas, I think it's like a drop-down option. Like yes or no, which is fine. On your work, I want to see this. Okay? Not a right triangle. All right. We're not going to worry about the graph. On your final exam, you're given the side links like example 1. Okay, so we'll cut it off here. Okay, and I want to start working on some classwork for tonight, which is 15.6, page 707 in your books. And then, of course, it's on big ideas. All right, so that's everything we're going to cover for 15.6. And insert here the last official lesson of honors pre-algebra. So congratulations.
I made it.